Lesson 6-4, page 316. It says factor the polynomial. Well, what are factors? Say you have this number 18. All right, well, what numbers make up 18? You got 2 times 3 times, let's see, make that 36. 2 times 3 times 6. Okay, these are called the factors. And this is called the product. All right, so we're going to learn to take, we know how to take them like 2 and then 18 and 3 and then 6. That's for factoring this right here. Well, now we're going to learn how to factor polynomials. We're going to learn how to factor polynomials. So step one, I don't know why I did that. Step one is to find the greatest common factor. This is always the first step, greatest common factor. Now what's the greatest common factor in there? You have x, all right? And if you take that out, that leaves you with x squared plus x minus 12. That's what you got left. So step 2, count the number of terms. 1, 2, 3. So there's 3 terms. When you have 3 terms, you do a check, and this a here is a 1. Okay? So you're going to 1 times negative 12. 1 times negative 12 equals negative 12. Not a problem. Now, we're going to find the factors of negative 12. Yeah, let's do it like that. And you got 1 and 12. 1 and 12. I'm going to need to move this over a little bit so I got more room. I got 1 times negative 12 equals negative 12. We got 1 and 12. 2 and 6, 3 and 4. All right, now this is negative, but that's positive. So that means the smaller number here must be negative. And what we're going to do is we're going to add these so that we can get, we got a 1 here, right? So we want it to equal 1. So negative 1 plus 12, that equals 11. That is not what we're looking for. Negative 2 plus 6 equals 4. Again, not what we're looking for. Negative 3 plus 4 equals 1. Excellent. That's what we're looking for. So we're going to have x times, and then we're going to put the negative 3 in there. Negative 3. And then we're going to put the positive plus 4 in there. Okay. And that factors it. Okay, that factors it. Now, I was wondering how we might be able to use our calculator to find the real ones. Okay, how we might use our calculator. And I did not, let's see here. I'm going to do it in Inspire. How are we going to use our calculator? Menu, oh shoot, on, we want a graph. Okay, tab, what do we got? X cubed plus x squared minus 12x. X cubed plus x squared minus, plus x squared minus 12x, and press enter. Now, where does it cross these at here? Menu 6, 4. Oh, let's see, menu 6, and then 1 for the zeros. Menu 6, 1, and then menu 6, 1. All right, you got -4, 0, and 3, right? -4, 0, and 3. Well, how does this correspond to what we're already doing? So what do we got here? You've got x equals 0, x equals 3, and x equals -4. That's what we had over here, right? That's what we got there. So now you subtract 0 from both sides and you just get x. You subtract 3 from both sides and you get x minus 3. You add 4 to both sides and you get x plus 4. Isn't that cool? That's how we get it. Now what about number 2 here, this x cubed plus 5? Well, 1, the greatest common factor, is just 1. There's nothing else. And now instead of 3 terms, we have 2 terms. 2 terms. So let's check the first term. That is a perfect cube, right? Perfect cube. But what about 5? 5 is prime. So number 2 is irreducible. All right. And I say it's irreducible under the real numbers. All right, good job, folks. Let's try number 3. Let's try number 3. Ooh, got a little happy there. Let's try number 3. What do we got here? X cubed minus 125. Step 1, greatest common factor. And that would be 1. No other greatest common factor. Step 2, how many terms? 2 terms. So when we have 2 terms, we're going to come in the x cubed. That is a perfect cube. What about this 125? That happens to be a perfect cube as well. It's the cube of 5. And let's see here. What if we go there we go. So that did work out. Now, this is what we call a difference of perfect cubes. And if you'll look on, I believe it's page 311, there is an algorithm that makes it finding these a whole lot easier. So the algorithm says x minus 5, or actually it says a minus b, and then you've got a squared, that would be x squared, plus ab, that would be x times 5, so we got 5x, plus, and then b squared, and 5 squared would be 25, okay? That's not hard. Let's take a look at number 4 here. What's the greatest common factor? We got an x, so we got x times, that's x squared plus 5x plus 6. Step 2, count the number of terms. Let's see, how many terms? 3 terms. We'll just write it there. 3 terms. Okay, remember how we did this before? 1 times, and we got a 6 here, right? 1 times 6. 1 times 6. Now, they are both positive, right? They are both positive. 1 times 6 is 6. They are both positive. So what are the factors of 6? We got 1 and 6, and we have 2 and 3. Now, this b here in the middle, that 5, 1 plus 6 is 7, does not work. 2 plus 3 is 5, that works. So we're going to have x times x x times 2 times x plus 3. X times x plus 2 times x plus 3. Okay? Now, this one here, you can't find it in the calculator. What do we got? X cubed minus, I did it again. Minus 125. And see, it goes through right there, but that's the only place. Okay, which is why you had this right here. But this one right here, let's try that one. And what do we got? We have x cubed plus 5x squared. X cubed plus 5x squared plus 6x. And press enter, and you'll notice it crosses all three. Menu 6, 1. Menu 6, 1. And menu 6, 1. So you have 0. All right. So that gives you x equals -3, x equals -2, and x equals 0. Well, let's see. Add 3 to both sides. You got x plus 3 equals 0. Add 2 to both sides, and you got x plus 2 equals 0. And then x plus 0 is just x. And notice that these are all the same. Good deal. Let's take a look at number 5 here. Number 5, step 1, greatest common factor. So what's the greatest common factor of 8 and 125? Just one. Step 2, how many terms? 2 terms. Okay, so we got 2 terms. Let's take a look. We'll bring this down. This happens to be 8 is a perfect cube of 2, and plus, and then again 125 is 5 cubed. Now, this is what we call the sum of 2 cubes. Actually, yeah. So this is going to become 2x, and again, that's on page 311. 2x plus 5 times, and then, well, it's going to be a squared, so 2x squared plus a times b, that's going to be 2x times 5. I said plus, that's supposed to be minus. There's a plus here, there should be a minus there. Plus, and then b squared. Okay, and that's gonna factor out a little bit, or that's gonna work out to be 2x plus 5 times 2 squared is 4, and then x squared minus 2 times 5 is 10, so you got 10x plus, and then 5 squared is 25. Okay. Well, let's look at number 6. We have a 2 goes into 6. Excellent. So we got 2, and then we also got an x, and we're left with x squared plus 3. Okay. Can we take it any further? Well, we took the greatest common factor out, so, and then 3 is prime, so that is as far as you can take it. Let's take a look at number 7. Let's take a look at number 7. 216x cubed plus 64. Those are both even, right? So 216 and 64. You know, I'm going to go over here to my calculator and, menu 2 and greatest common divisor 5. Who'd have thought? 216 and 64. Oh, 8. Well, that happens to be 8 squared, and that's 8 cubed. So we can take an 8 out of there. Maybe, and what is that later? That's 3x cubed plus 2. What if, let's try something else. The cube root of 216 is 6. And what about the cube root of 64? 4? I'm thinking I don't need to take, what do we got? 6 and 4. Uh, 6 and 4, 3 and 2. That's a 3 and a 2. Okay. So what if I take a 2 out? So 216, 216 divided by 2 is 108. No, I'm not going to do that. I'm going to work with perfect cubes. So the greatest common factor was 8. So we take an 8 out, and that leaves you with what's 3x cubed plus 2. And there we go. But this is a perfect cube. What if you said, what if you said 6x cubed plus, and that was 4 cubed, and then that would give you sum of 2 perfect cubes. That gives you 6x plus 4. Well, I don't know why I wrote 2 there. Well, I do know why. And then we're going to have, it's going to be 36x squared plus 6. That's be 24x plus, and that would be 16. See, you got positive, or you got even numbers all the way through it. So there you go. That's why you always find the greatest common factor first. Let's take a look at this one here. What do we got? 8 and 64. Well, 8 goes into 64, so you take the 8 out, and you got x cubed minus 64. That would be 2. So that gives you x cubed minus 2. And I'm looking at this, and you know, I just now noticed this. 64 divided by 8 is 8. Well, 216 divided by 8 is 27. So over here, take that 8 out, and you got 27x cubed plus 8. Well, again, you got two terms. This is 3x cubed plus, and then that's 2 cubed. And all that's multiplied by 8. So you got 8, and then 3x plus 2. And then 3 squared is 9. X squared is x squared. 2 times 3x would be 6x. But it's not, since it's plus here. That means it's minus there. Minus there. And then 2 squared is 4. And there we go. Okay, and remember those algorithms are on page 311. So we took an 8 out of here, x cubed minus 8. I was doing square root for some reason over there and started doing it over here as well. We've got x cubed minus, and that's 2 cubed. Okay, so again, we have a difference of cubes. Well, perfect cube actually, 8, and then we have x minus 2, and then x squared plus 2x plus 4. Okay, there we go. Now we're back on track. I need to practice these more, don't I? All right, what do we got here? Step 1, greatest common factor, that's 10. We got x cubed minus 8, and we just did that one there a minute ago. So that's going to be 10 times x minus 2 times x squared plus 2x plus 4. Excellent job. Looky here. We can take an x squared out. That's 2x squared plus 7x plus 5. All right, step 2, how many terms? 3 terms. Okay, 2 times 5 is 10. 2 times 5 is 10. But you notice this is prime and this is prime. So I'm going to show you how this is going to work. You got x squared, and then you got 2x, and then you got x, because 2x times x is x squared, and you got a 5 there, and those are all positive. We got plus and plus. Now, the 5, I believe will go here. That's 5x, and that'll be a 1. Okay? Cool. Number 11, the greatest common factor is x, and you got x squared plus 10x plus 16. All right, well, so we got 16. What are the factors of 16? 1 and 16, 2 and 8, 3, 4, and 4. Now it's positive all the way through, so we're going to add these, and that's going to give us 17. That does not equal 10. 2 plus is 10, so there we go. We're going to have x times x plus 2 times x plus 8. All right, let's take a look at number 12 here. X cubed. So the greatest common factor is 1. No other greatest common factor. Let's take the cube root of 9769. 9769. Did I do that right? 9769? I did. Oh, 21. And we'll just check. 21 cubed. 9261, 22 cubed, 1064. So it looks like number 12 here is irreducible. And we can check that. Let's check that. I can't check that. All right, folks. Great job. I'm going to put a couple on the form for you to try. Oh, I'm sorry. We need to do grouping. We didn't do grouping. You almost got out of it. You almost got out of it. All right. You'll like grouping. Grouping's fun. So let's see here. What do we got? We got x cubed plus 8x squared plus, all right. Grouping, we're going to group the first two, and then we're going to group the second two. What's the greatest common factor in the first group? We got x squared. That leaves you with x plus 8. In the second group, we got 6, and that leaves you with x plus 8. So now you can, x squared and 6, that becomes a thing, x squared plus 6. And then since this is both, that is x plus 8. All right. And what we have just done is reverse the distributive property. That's right, folks. We have reversed the distributive property. Now let's take a look at number 14 here. So we're going to put those two in a group. We'll put plus, and then we'll put those two in a group. We can take an x squared out, and that leaves you with x plus 4. And we can take a -1 out, and that leaves you with x plus 4. So we have x squared minus 1 times x plus 4. Now, the x squared minus 1, that's the difference of perfect cubes. Again, it's on page 311. That's x plus 1 times x plus 4. See here, x plus 8, nothing to reduce. You had x squared plus 6. 6 doesn't have a perfect square, so there's nothing you could have done about that. But here, -1 is a perfect square. X squared minus 1. Well, 1 is a perfect square. So we got x minus 1. That was supposed to be x plus 1 times x plus 4. All right. Now we're done. Folks, y'all have a great day, and we'll see you tomorrow in class.